Look at this table. Repeated failed logon attempts and same account name, Enrique, and same source network address, same reason. This is same failure reason. This is not a normal user mistake, that's a clear attack pattern. You will know how to find this pattern in Splunk, understand what it means, and explain your findings clearly. Before we start querying, I want to show you where this data is coming from. This is Windows Event Viewer and security logs. So here is an event ID 4625 right here. So Windows generates this event natively every time a logon attempt fails. Splunk collects this log and makes it searchable at scale. Event code 4625 is the Windows security event for a failed logon attempt. Every time someone tries to log into a Windows machine and fails, this event is recorded. When Splunk collects that log, every failure ends up here. When somebody tried to log on with wrong password, wrong username, Splunk collect that logs and show up here. Before we run any queries in Splunk, look at the raw event. Here is the raw event. You need to understand what fields are available before you start searching. This habit will save you a lot of time. There is one field in this event that most tutorials skip entirely. It's a hexadecimal code. It tells you exactly why the logon failed. So here I prepared some notes for you guys. So if we see that OXC, a couple of 0 and 6A, that means incorrect password. And this is the most frequent cause of failed logon. So here if you see 64 in the end, username does not exist. That means the username entered does not match any account in the database. This often indicates a typo or brute force attempt using common usernames. So 34 means user account locked out. The account has been automatically locked because the user exceeded the threshold for failed login attempts. And if you see 71, it's expired password. Actually, these four are most common ones. So why does this really matter? So if you see one IP hitting dozens of usernames that do not exist, that is account enumeration. So the attacker is guessing account names. If you see one IP hitting the same username with the wrong password over and over, that's a brute force attempt. The attacker knows the account is real. So it's same event code, but completely different threat. So substatus is what separates them. So guys, I want to start from scratch, you to see from the beginning everything. So let's hit Splunk Enterprise. It's forwarding us to localhost 8000. Search and reporting. So let's run the first query here. We want to see which accounts are being targeted. To do that, I'm typing index main, event code 4625. So let's say start sound by account name. Here it is. Yeah. So I want to notice something before we look at the results. So first I'm using index equal main here. That is where the Windows security logs live in this environment. In your own setup, check your index name first. And notice the field name. I mean, it's as you can see, this is account name. So not user, not username, not target username. Splunk extracts Windows security event fields differently depending on the version and configuration. In some environments, this field is called target username. In this one, it is account name. And this is exactly why you expand the raw event before writing queries. So you verify the field names first, okay? So the results show which accounts received the most failed attempts, sorted from the highest to lowest. If one account sits far above everything else, we can see Henrique. So if it's like that, it's being targeted specifically. So that is your starting point. So guys, let's add the source IP address. In this environment, the field is called source network address. Here it is. As you can see, our source network address. Now we can ask a more useful question. Here we can see one IP, many different accounts, and lower count per account. That looks more like a spray. The attacker tries one common password across many accounts to stay below lockout threshold. The shape of the data tells you which direction to look. But to know exactly what type of attack this is, we need one more field. So let's add substatus. This is a query that makes the investigation specific. We add substatus. Now, each row tells you not just who and where, but what type of failure. As you remember, if it's ending 6 and A, that means correct username, wrong password. This is kind of brute force signature. If it would be 6 and 4, that means username does not exist. And we could say enumeration. We could interpret the situation. And now we are also interpreting by saying, this is correct username, wrong password, because substatus hexadecimal code is ending 6 and A. So it could be brute force signature. So guys, let's put the picture together. We can see repeated failed logon attempts against the same account from the same source address with the same failure reason. The account is Enrique. The source address is 127.0.0.1 and the substatus value is our hexadecimal code ending with 6A, which means the username is valid, but the password is wrong. If I had to write this as a SOC finding, I would summarize it like this. Source 0.0.1, target account, Enrique, event count 15, substatus, our hexadecimal code, like this, and pattern. Consistent with targeted brute force. So in summarized, in this video, we learned that event code 4625 means failed logon, and substatus means why it failed. So logic of the three queries that we learned in this video. Count by account name means who is targeted. When we add source network address, that means where is it coming from. And after that, when we add substatus, we are trying to investigate what type of failure is that. All three queries are in the GitHub repo with comments explaining each field. So this is a simple project, but it teaches a real investigation workflow. You start with a raw Windows event, move into Splunk and use a few focus queries to explain what happened. If you found this useful, please like and subscribe. More videos like this are coming. See you there.